Hello friends, welcome back to our channel. In this video, we are going to learn some more basic concepts relative to vectors. So let's start with the topic unit vector. A unit vector is defined as a vector whose magnitude is always 1. Whatever the direction is, the direction does not matter. The only necessary condition is its magnitude should be 1. So we can write a vector whose magnitude is 1 is called as a unit vector. Suppose we are given that a vector is a unit vector. Let a vector is a unit vector. Then from this expression we can deduce that the magnitude of this a vector should be equal to 1. This implies that mod of a vector should be equal to 1. The direction does not matter in this case. Please note down by pausing the video. Now we will see representation of unit vector. A unit vector can be represented as a cap. It is read as a cap, and a cap suggests that this vector is a unit vector. Now, one caution we have to remember that in the examination, if the cap is written with the vector and the word unit vector is not used for that vector before writing the vector, then the cap may not represent unit vector. So it is necessary that the question writes that it is a unit vector. It is important from examination point of view. Now we are going to see the utility of unit vector or use of unit vector. Let us suppose we are given a vector, a vector. Let a vector be any vector such that mod of a vector is not equal to 0. It can be 1 or any other number except 0. Then the unit vector along the direction of this a vector can be represented as a cap is equal to a vector divided by its modulus. In this way, the unit vector is represented. We can also prove this result. We have to prove that a cap is equal to a vector divided by magnitude of this vector. This left hand side and right hand side both both sides are equal. Now we know that in this side the magnitude is 1. Now from right hand side we have, let us take the magnitude of right hand side. Magnitude of A vector divided by magnitude, this is equal to magnitude of A vector divided by two magnitudes, we can suppress it to a singular one. So this is equal to 1. So the magnitude of right hand side is also equal to 1, and the magnitude of left hand side we already know that it is equal to 1. So it is proved. Now we can denote a vector as magnitude of that vector multiplied by the unit vector along that direction. From this expression we can deduce this expression. It is also important. This quantity represents the magnitude and this quantity represents the direction. So both the properties of a vector are satisfied. Now the basic use of unit vector is to denote the direction. It is used to denote a direction of the vector quantity. Next we are going to write a note. Suppose we have two scalars P and Q, that means scalar quantities. P and Q, these are scalars, not vectors. Then the first property is P multiplied with Q times A vector can also be written as Q multiplied by P times A vector, and can also be written as PQ multiplied with A vector. The second one is P multiplied with A vector divided by Q can also be written as P divided by Q multiplied by A vector. These are some general operations which are not normally used. Next we are going to see vectors versus vectors. The first one is equality of two vectors. That means when can we say that two vectors are equal? We are going to see that. Equality of two vectors. Two vectors are said to be equal if they have the same direction as well as the same magnitude. So we can write two vectors A vector and B vector are said to be equal if they have, number one, same direction, and the second condition is same magnitude. Then and only then we can say that both these vectors are equal. Their magnitudes should be same and their directions should also be same. That means we can write it as same direction can be represented as A cap should be equal to B cap, because these are directions along the direction of the original vectors, and So both their magnitudes should be equal and both their directions should be equal. Next, we are going to see some algebraic operations of vectors. Operation first one is addition. In case of algebraic operations involving addition, the addition of vectors is valid. That means one vector adding to another vector is valid. It is valid. And the next one is subtraction. It is also valid. We are going to look forward upon these statements with some more detail later on. Multiplication of vectors is also valid, but division of vectors is invalid. It is not valid or invalid. We cannot write one vector divided by another vector. It is meaningless. So a vector can never be written in the denominator position of a fraction. So next we are going to see addition of vectors. Before that, one more concept we are going to look forward is, suppose this is a vector, A vector. Then minus A vector means the magnitude should be same, but the direction gets inverted. So this is the meaning of the negative sign. This is plus A vector, this is minus A vector. The magnitude remains same in both the cases. Next we are going to see addition of vectors. The first case is addition of collinear vectors. Collinear vectors means the vectors having same direction or opposite direction. Suppose we have this vector A vector and its magnitude be mod of A vector, and we have to add this vector with another collinear vector whose this vector, which is B vector, and its magnitude be mod of B vector. Then the result of this summation is going to be both these magnitudes get added up. The length will be twice this length, or this length is sum of the lengths of this A vector and B vector, and we can write it as A vector plus B vector, and its magnitude is going to be mod of A vector plus mod of B vector. So only in this case A vector plus B vector is only in this case the magnitude of A vector plus magnitude of B vector is going to be the magnitude of A plus B vector. That means if we are given that the magnitude of A plus B vector is equal to mod of A vector plus mod of B vector, then from this statement we can infer that both these vectors are pointing in the same direction. This implies that A vector and B vector have same direction. This is the inference of this statement, because this, from this statement we have derived this statement using this example. Next we are going to see if the directions are opposite, then what happens. Suppose we have this as A vector and we have to add this with this B vector, which is in opposite direction to this, to the direction of this A vector, and its magnitude is A vector. Its magnitude, suppose this is a little bit smaller one, and its magnitude is B vector. Then this can be equated as a vector which will be pointing along the direction of the A vector, because its length is larger. So it will be, the length of A vector plus B vector will be the subtraction of this length from this length, which is equal to about this length, and the direction of this vector A vector plus B vector will be along the direction of the A vector, because its length is more in magnitude. And this can be written as, and it's the magnitude of this A vector plus B vector can be written as mod of A vector minus mod of B vector. From this example we can deduce that mod of A vector plus mod of B vector can be equal to mod A minus mod B. We can generalize it as by giving mod. Suppose we are given this statement, then this statement infers that the direction of A vector and B vector are opposite. It implies that A vector and B vector have opposite directions. In this way, we can add collinear vectors. Next, we are going to learn the addition of non-collinear vectors. Addition of non-collinear vectors. Before that, we are going to see the meaning of the resultant. Suppose we are asked the resultant of two vectors A vector and B vector, then we are supposed to find the sum of the two vectors. That means, suppose we are asked the resultant of A vector and B vector, then the meaning of this statement is A vector plus B vector. It is never subtraction, it is addition. Non-collinear vectors means the vectors which do not have either the same direction or in opposite direction. That means, suppose let us take this is as A vector and this vector is B vector. Then these two vectors are non-collinear because these are not in same direction or in opposite direction. Now, for finding the addition of non-collinear vectors, we have two laws. The first one is the triangle law of addition. Law of addition. And the second one is the parallelogram law of addition. First of all, we are going to look at the triangle of addition, and then further on we will look after the parallelogram law of addition. In the triangle law of addition, we are going to use the head-tail combination. Suppose we are given a vector, this as a vector and this as b vector, and we have to find the resultant of these two vectors, that means the addition of these two vectors. Then what we are going to do, we are going to move this b vector parallel to itself and move to this position until the tail of the b vector coincides with the head of the a vector. That means we have to put the head-tail combination. In this formula, head-tail combination is used. Now we are going to shift it in this parallel direction and move till the tail of the b vector coincides with the a vector. That means resultant can be written as, in this way we have drawn the a vector and we are going to shift it in this direction. So we are going to get this b vector. Then the resultant of these two vectors can be written as this vector, whose head is going to coincide with the head of this b vector and the tail is going to coincide with the free tail of the a vector. This is known as the triangle law of addition, as this forms a triangle. That means the third side represents the resultant of this of the sum of these two vectors. We can take another example as, suppose this is a vector plus this is b vector. Then if we have to find or draw the resultant vector, we can write it as, first let's draw the a vector as it is and the b vector in this position as b vector. Then this is the resultant vector, r vector. We can put a bar over a vector or simply in this way. Both mean the same thing. And r vector is a vector plus b vector. In this way, the triangle law of addition is used. Next, we are going to look into another formula, that is the cosine law, which is especially important in mathematics. Let us take a triangle. We are not going to look into its derivation. Suppose we have a triangle ABC and the length of the side BC is represented by small n. The length of the side AC is represented by small b, and this is small c. Then let us suppose ABC represent the vertices of the triangle as well as the angles of the triangle. Then we can write cos of angle A is equal to b square plus c square minus a square upon twice bc. Similarly, we can write cos of b as a square plus c square minus b square by 2ac. and the third one is cos of c is equal to a square plus b square minus c square by 2ab. This is the cosine law. It is important to note this formula. Next, we are going to see how to find the angle between two vectors. What is the actual meaning of angle between two vectors? Angle between two vectors. Let us suppose this is the vector A vector and this is the vector B vector. Now, geometrically, to find the angle between two vectors A vector and B vector, we have to place the two vectors in such a way such that the tails of the two vectors coincide, and measuring the smallest angle between them. The smallest angle will be the angle between the two vectors. So let us suppose we move this vector parallel to itself, then the resultant, this is B vector and this is A vector. Both the tails of the two vectors are coinciding, and this angle is the smallest angle theta, and this is the larger angle alpha. Here theta is known as the angle between the two vectors. Angle between A vector and B vector. Suppose we are given another example. This is suppose B vector and this is suppose C vector. We are supposed to find the angle between B vector and C vector. Then this combination is not ideal to find the angle between these two vectors, because here the head of this C vector is coinciding with the tail of the B vector, but both the tails should coincide. So first of all, we have to make both of them move such that the tails of both the vectors coincide. So let's move this vector parallel to itself. So this is the C vector. Now both the tails of these two vectors are coinciding. So this angle theta is known as the angle between the two vectors. This is the actual meaning of the angle between the two vectors. Next, we are going to find the resultant of two vectors, A vector and B vector, and suppose the angle between them is given. Resultant of two vectors with angle theta. Let us suppose the angle between the two vectors is theta. Suppose this is A vector and suppose we have vector A vector in this way and B vector in this way, then its resultant can be written as this vector R vector. We have already discussed. Now we are given that the angle between these two vectors is theta. That means this is, we have moved parallel to the vector A itself, and this is A vector and this angle is theta. Then by geometry, this angle is phi minus theta, or 180 minus theta. Let us suppose this angle is alpha. Then by cosine rule we can write this as, before that we can represent the magnitude of this R vector as simply R, and the magnitude of this A vector as simply A, and the magnitude of this B vector as simply B. So we can write by the cosine rule, cos of pi minus theta is equal to a square plus b square minus r square, a square plus b square minus r square divided by twice a b. Now we are going to simplify this result to find the value of r. That means the r is basically the magnitude of this r vector is represented as r, the magnitude of a vector is represented as a, the magnitude of this b vector is represented as small b. Now cos of pi minus theta is basically minus cos theta, and we have a square plus b square minus r square to ab. Now rearranging these terms, we further get r square is equal to a square plus b square plus 2ab cos of theta, or we can write r as root under, we are not putting here plus minus sign because this r represents the magnitude of the r vector, which is always positive. So we already know that this is a positive quantity, so that is why we are not putting plus minus sign, although in maths it is important. This is the formula to find the resultant. Now we have discussed method 1 of finding the resultant of two vectors, a vector and b vector, when their angle is given and the magnitudes are also known. A, b and theta are known. Then we can find the magnitude of the resultant vector directly using this formula. Now we can discuss another method of finding the resultant. Let's draw the figure again. Let us suppose this is a vector, this is b vector, then this is the resultant r vector. This is angle theta. Let's do some construction. Let us draw a perpendicular from this point. Let's name this vertices as A, B, C, D. Now we are to find the resultant, the magnitude of the resultant vector. We have cos theta. Cos theta is equal to CD upon this AC, and sin theta as AD upon AC. Now AC, we can write AD upon AC is equal to magnitude of this B vector, which is equal to B, and here also we can write it as CD upon B. Then we have CD is equal to B cos theta, and from this expression we get AD is equal to B sin theta. We can redraw this figure by eliminating this line AC. Then we are going to get this right angle triangle ADB, and this is R. R is basically the magnitude of this resultant vector, and this is the length of AD is B sin theta, and the length of BD is BC plus CD. BC is A plus CD is B cos theta. Next, in this triangle we are going to apply the Pythagoras theorem. By applying the Pythagoras theorem, we get r square is equal to the square of this side, that means b sine theta whole square plus the square of this side, a plus b cos theta whole square. We are going to get b square sine square theta, and from this expression also b square cos square theta. So if we take b square common from the for both these terms, we are going to get b square. So we get b square plus a square plus twice ab cos theta. Again we are going to get the same result. Twice ab cos theta. In this way we can find the resultant of two vectors, a vector and b vector. We have discussed the two methods of finding the resultant. One more thing we have to discuss is, let us go back to the previous diagram. This was a plus b cos theta, it was b sine theta, and this was r, and it was alpha. So we can write tan alpha. This alpha angle is also important. It is also asked in examination. Tan alpha is equal to b sine theta upon a plus b cos theta. We can remember this formula. It is also helpful in finding alpha. Alpha is equal to tan inverse of this material which is written in right hand side. Next we are going to discuss a simple illustration based on this formula. Suppose, let us take one example. Let this is a vector and this be b vector, and this is the resultant vector. We are given that magnitude of a vector, which can also be written as a, is equal to 4. Magnitude of b vector, which can also be written as small b, is equal to 7, and the angle between these two vectors, which is this angle theta, is equal to 30 degree. Then we have to find the resultant of these two vectors. That means we have to find the magnitude of the resultant r vector. Then by using the direct formula I can write r is equal to root under a square plus b square plus 2ab cos theta. A square 4 square plus 7 square 2 not 4 not 7 cos of 30 degree. We are going to get 4 square 16, 7 square 49, 4 the 8, 8 sevens are 56, cos 30 is root 3 by 2, so 28 root 3. I hope all of you can simplify this result. Let us suppose we are also required to find this angle alpha. We can write it as tan alpha is equal to b cos b sin theta upon a plus b cos theta. Then we have the value of b as 7 sin 30 degree upon a plus 4 plus 7 cos 30 degree. I hope you can find this value and find a value and term alpha as tan inverse of this simplification.